Okay, welcome back. Answer your attendance, Afla,
Present, Miss.
Ajmina, Amaya,
Present, Miss.
Tulya, Drishya, Jyotish, Karthik, Kavya,
Present, Miss.
Kedas, Neeraj, Rangeet, Neeraj, Rangeet, Vaishna, Vaishnav, Anjali, Shruti.
Present, Miss.
Okay. Atulya is there. Jyotish,
Present, Miss.
Karthik, then Anjali, Vaishnav, Vaishna, yeah, Nachiketas, I marked it.
ഞാൻ പ്രസന്റ് ആണ്.
Rankeet present only. Vaishna, Vaishnav, Anjali, Atulya, okay, Atulya is there. Karthik. Right. Can you see the slides?
Yes, Miss.
Yes, okay. One second, it's not getting. Yeah, morning we were discussing about the email system architecture, and I have told you you have got two different types of protocols. One is the SMTP protocol and the other one is the POP protocol. So SMTP, I have told you, that is simple mail transfer protocol, and that is used or it is responsible for transmitting an email between sender and recipient. That means you are making use of from your source to the mail server. Yeah, from your source to the mail server and also between two mail servers, you are making use of this SMTP protocol. Now the next protocol, what you're using is called it as the POP3. POP3. POP, it is generally it is called it as POP. The version 3, if you are using, it is called it as POP3. And, or instead of POP3, you can make use of this IMAP4 protocol also. But in syllabus, you don't have this IMAP4. You just have only this POP3 protocol. Okay. Now, POP or the post office protocol. This is an email protocol. It is used if you want to retrieve email from the email server, you are making use of this POP3 protocol. Now suppose if you use an email client such as your Microsoft Outlook, now that will be configured with this POP3 or this IMAP protocol. Now what is its function is, if you want to retrieve your email on a computer, you will be making use of this. Okay. And this protocol that will be present in this, I mean, if you are using your tablets or smartphones also, you can make use of this protocol. Okay. Now, so POP3, what it will do is it will download the email to your device from a mail server. You have your mailbox. If you want to download your email from your mail server, you are making use of this POP3 protocol. Now, what is its the thing is, it is only downloading option. It is not, you don't have any, I mean, you're not able to download any other folders like sent items or draft or deleted files. Whatever is there in your inbox folder, you will be able to download it with the help of this POP protocol, right? Now, this POP protocol, now how the exchange of commands and responses in POP3 happens. So POP protocol, it is very simple and limited in functionality. Now your POP3 client software, it will be installed in your recipient computer, and your server POP3 software, it will be installed in your mail server. Now this is the diagram that shows how the commands are exchanged between, you are having a POP3 server and you are having a client. Now, as far as client is considered, I have told you Alice and Bob, they are just sending in in a conversation for email, they are sending. So here Bob's computer is acting as the POP3 client. Okay. Now, the mail access, actually it starts with the client. This is the client who wants to download the mail. Okay. So when the user needs to download an email from the email box on the mail server, the POP3 or this will be activated. Now what happens? The client will open up a connection to the server on some TCP port. You have a TCP port between these two, and the client will be making a connection to the server. Now what it does, it sends the username and the password to access the mailbox. That is what we are doing, right? When we are just want to download an email, what we will do, we will just open up, we will type our username as well as our password in order to access the mailbox, right? Now the user can then list and retrieve the mail messages one by one. You will have a list of messages, and based upon our requirement, you will be retrieving one by one. Now this POP3, it has got two modes. One is called it as the delete mode, and the another one is called it as the keep mode. Delete mode means the mail will be deleted from the mailbox after each retrieval. Whenever we are retrieving it, each mail, it will get deleted after that. Okay, so that is happening in delete mode. Now in the keep mode, the mail remains in the mailbox after retrieval. Once we are retrieving also, it will be present in our mailbox. Okay, so this is just a short explanation on this POP3 protocol. So POP3, it's important is if you want to retrieve your email from the mailbox, you are making use of this POP3 protocol, right? This is how the diagram goes. Here only you are making use of this part. Is only you are making use of this POP3. Now, so this can be installed in your systems. Okay, now if you want to access it, what you will do, you will open up a connection. Now you will be typing your username and password. Then the server will be introducing some list, and you will be able to access those emails one by one. Okay. Now, the next type of protocol is called it as MIME. M-I-M-E. It is called it as multi-purpose internet mail extension. Multi-purpose internet mail extension. Now, what is this? Now, I have told you this email, it has got a very simple structure. Okay, now how it can send the message is only in the form of NVT 7-bit ASCII format. So in email, they can send the message only in this NVT 7-bit ASCII format. So MIME is nothing but it is a supplementary protocol that allows the known ASCII code. The known ASCII code, it will be at the user agent part, and that will be converted to a 7-bit NVT ASCII code. Okay, so this will convert, this MIME protocol, it will convert the known ASCII code to a 7-bit NVT ASCII code. that is happening at the center side. And this will be delivered to the MTA client at the center, and this will be transferred over the internet. And at the receiver side, the MTA client access that. And again, you are making use of a MIME protocol. You are converting back into non-ASCII code, which is readable by the, which is you are converting it into the original data where the user can access it. Okay, now I have told you, you have got, when I have told you, you have got an email format, right? Or the structure of the email, you have got the header as well as the body part. Now, usually this MIME, it is defined in between this, between the email header and the email body, you have got the MIME headers. And that will be added to the original email header section in order to define the transformation parameters. Now, there you will be defining your MIME version, content type, content transfer encoding, content ID, content description, whether it is textual explanation of non-textual contents. So all these details are described in between the email header. This is the original header actually, and between the email body. Between these two, your MIME header will be described. Okay, so this is about the protocol MIME. MIME, if you want to convert non-ASCII code to 7-bit NVT code, you are making use of this MIME protocol. Right? Understood the two protocols in emails architecture, what you're using? Usually 3 are there. SMTP is there. Then other one is POP, and the other one is this MIME. MIME is just for conversion of ASCII to NVT ASCII code. Right? Understood these two? Yes or no?
Yes, miss.
Yes. Okay. Okay, so I will just stop it here. Now 4 more topics are there that will be continued on the next week. So by that, the 5th module will be completed. And by the meantime, now Afla, how much time you need for the presentation?
10 minutes.
10 minutes. Okay. After that 10 minutes, I'll be just solving that Dijiksha's algorithm problem. Okay. Now Vaishna is there. Vaishnav and Anjali.
Yes, miss.
Anjali is not there, right?
Yes, miss.
Yeah. Right. Okay. Just Afla can proceed now. All of you, I'll be sending the slides today itself. Now all of you has to get thorough with the concept what she is explaining. The coming Tuesday, I will be asking questions based on that. Okay, simply sending and without seeing coming note, it is not, I don't want that. Second time I'm taking the topics with you people only, then, but you have to study this, and this is for you. Just remember that. Okay. Afla, you can proceed.
Okay, can you see the slides?
Yeah.
Well, the
But
question
not
is
much
explain
clear
the various.
actually. It is not so clear. Can you just put it in the other? The ratio can be increased, I feel. The letters are not clear. Others, what about others? Nachiketas,
Yes, miss.
how is the slide visibility for you?
Is it clear?
Is it clear?
Yeah. Yes, miss.
It's clear. For me, it is not clear. Okay, anyway, you just continue. Right.
മിസ് ആ ഫോൺ ഒന്ന് റൊട്ടേറ്റ് ചെയ്തിട്ടുണ്ടെങ്കിൽ
Yeah,
കറക്റ്റ് ആയിട്ട്
you just
പോകാം.
rotate it. Yeah, it's clear.
The question is explain the various congestion control mechanism to alleviate congestion after it happens. Okay, that is closed loop congestion. In closed loop congestion, control mechanism try to alleviate congestion after it happens. That is, try to remove the congestion after it happens. There is several mechanisms have been used by different protocols. That is back pressure, chalk packet, implicit signaling, and explicit signaling. First is back pressure. The techniques of back pressure refers to a congestion control mechanism in which congested nodes stop receiving data from the immediate upstream node or nodes. This may cause upstream node or nodes to become congested and they in turn reject data from their upstream node or nodes. And so on. Back pressure is a node or node congestion control that starts with a node and propagates in the opposite direction of data flow. And the back pressure techniques can be applied only in virtual circuit network. Then here is figure. This is source and this is destination. There is four intermediate nodes, and at node 3, a congestion is occurred, and node 3 will back pressure to the upstream. It inform to the upstream to slow down the packets. Node 3 is informed to node 2 by back pressure to slow down, and node 2 become congested and informed to node 1, and node 1 congested, and that will be informed to the source. Then all are congested now, and pressure of 3 will be moved back to remove the congestion, and it is automatically sent the packet. This is the working. And next one is chalk packet. Chalk packet is a packet sent by a node to the source to inform it of congestion. Note that the difference between the chalk packet and the back pressure. In back pressure, the warning is from one node to the upstream node, although the warning may be eventually reach the source station. In chalk packet method, the warning is from the router which has encountered congestion to the source station directly. The intermediate nodes through which the packet has been traveled are not warned. We have seen the example of this type in ICMP. Here is also a source and a destination. There will be 4 intermediate nodes, and in 3 congestion occurs, and these 3 will directly send chalk packet to the source. This is not disturbing the upstream packets. Directly, the congestion node is sending chalk packet to the source. The source can overcome this. That is, here the congestion node sends a special type of packet, that is chalk packet, the source. This is done. This does not disturbing the upstream nodes. And next one is implicit signaling. In implicit signaling, here there is no communication between congested node and the source node. Here, the source guesses there is a congestion in the network when it does not receive any acknowledgement from the receiver. That is called the implicit signaling. Whenever a congestion is observed by the source becomes slow down. And next one is explicit signaling. It is nothing but the congestion node explicitly sends a signal to the source or destination to inform about congestion. But it is different from the chalk packet. which is sending direct signal to the source or destination. That is, congestion is occurred in the intermediate nodes. But in this, it is different from the choke packet. Choke packet is directing the data to the source, do not disturbing the intermediate nodes. Here, explicit, we are just sending the signal into the packet that carry the data, and it can occur. Here, explicit signal is done either forward or backward direction. In backward signaling, a bit can set in a packet moving in the direction opposite to the congestion. This bit can warn the source that there is congestion and that it needs to slow down to avoid the discarding of packets. That is, it is intimating the source to slow down the sending packet. And in forward signaling, a bit can be set in a packet moving in the direction of congestion. This bit can warn the destination that there is a congestion. The receiver in this case use policies such as slowing down the acknowledgement to alleviate the congestion. That is, in forward signaling, intimating the destination to slow down acknowledgement to remove the congestion. In backward, it intimating the source to slow down sending the packet, and in forward, it intimating the destination to slow down acknowledgement to remove the congestion. That's all.
Okay, thank you, Afla. Good presentation. I hope you all understood, got a clear idea on closed loop congestion control. Closed loop. So ഇതുവരെയും രണ്ട് ടോപ്പിക്കാണ് കവർ ചെയ്തത്. ഒന്ന് ഓപ്പൺ ലൂപ്പ് കൺജഷൻ കൺട്രോൾ മെത്തേഡും ക്ലോസ് ലൂപ്പ് കൺജഷൻ കൺട്രോൾ മെത്തേഡ്. ഓപ്പൺ ലൂപ്പിനകത്ത് കുറച്ച് പോളിസീസ് പഠിച്ചു. ഇനി ക്ലോസ് ലൂപ്പിനകത്ത് യു ഹാവ് ഗോട്ട് 4 മെത്തേഡ്സ്. വൺ ഇസ് ബാക്ക് പ്രഷർ, ചോക്ക് പാക്കറ്റ്, ഇംപ്ലിസിറ്റ് സിഗ്നലിംഗ് ആൻഡ് എക്സ്പ്ലിസിറ്റ് സിഗ്നലിംഗ്. So you should be able to remember the terms like all choke packet, back pressure. Now choke packet and back pressure, when it is asked, you have to draw the diagram and then represent it. So it will be easily understood by the evaluator. Okay. So നിങ്ങൾ എഴുതുമ്പോൾ അതിന് പ്രോപ്പറായിട്ട് എന്താണ് അലീവിയേറ്റ് എന്നുള്ള മീനിങ് വരുന്നത് റിമൂവ് എന്നുള്ളതാണ്. റിമൂവ് എന്നുള്ളൊരു അർത്ഥമാണ് വരുന്നത്. അപ്പോൾ രണ്ടും കൂടെ കൺഫ്യൂസ് ആകരുത്. ഓപ്പൺ ലൂപ്പ് പ്രിവെൻറ്റ് ചെയ്യുകയാണ് വരാതെ ഇരിക്കാൻ വേണ്ടി. ബട്ട് ക്ലോസ് ലൂപ്പിനകത്ത് ഇറ്റ് ഹാസ് ഹാപ്പൻഡ്, കൺജഷൻ വന്നു, അതിനുശേഷം അതെങ്ങനെ റിമൂവ് ചെയ്യാം എന്നുള്ള പ്രോസസ്സാണ് അഫ്ല എക്സ്പ്ലെയിൻ ചെയ്തത്. സോ ഡോണ്ട് ഗെറ്റ് കൺഫ്യൂസ് ബിറ്റ്വീൻ ദീസ് ടു, റൈറ്റ്? ഓക്കെ, right? I hope you understood. Afla just send the slides and I'll be just putting it in the Linbase. Okay, right. Now at the topic I have just told to who all? Amaya and Vaishna. അല്ലേ? നിങ്ങളുടെ ടോപ്പിക് ക്വാളിറ്റി ഓഫ് സർവീസ്. ഒരാളത് ക്വാളിറ്റി ഓഫ് സർവീസ്, അതിൻ്റെ രണ്ട് ടോപ്പിക്സ് ഉണ്ട്. ക്വാളിറ്റി ഓഫ് സർവീസ് എന്താന്ന് പറയുക. Now, what are the techniques that are used to improve quality of service? Adila rendu method Amaya has to explain and 2 methods Vaishna has to explain, right? And the next topic is about the data traffic and flow characteristics. Our rendu topic Rangeet has to prepare and present it. So നിങ്ങൾക്ക് ഡൗട്ട് ഉണ്ടെങ്കിൽ സ്ലൈഡ്സ് പ്രിപ്പയറിന് ശേഷം you have to send it to me. I'll just correct it and send back to you, right? Now the അടുത്ത ടോപ്പിക് ട്രാൻസ്പോർട്ട് ലെയറിനെ പറ്റി കുറച്ച് like what is its function when you are comparing with the other layers, that Jyotish has to explain. I will detect the question in the next week. Anyway, you just read from the textbook about the transport layer. And UDP protocol, Vaishnav has to explain, and TCP, Nachiketas has to explain, right? So this much is there for the next week. QoS, Amaya and Vaishnav, data traffic and flow characteristics, Rangeet, transport layer, its various methods to overcome the limitations of network layer, that should be explained by Jyotish. Then UDP protocol by Vaishnav and TCP by Nachiketas. Okay. Now, all of you take down your notebook and just draw the diagram, what it is asked for the exam. All of you take your notebook. and just take down this problem, what it is. Dijkstra's algorithm. Make it fast because time is 11:35. We should be able to complete it. Edito, all of you, yes or no?
Yes, Miss.
Yes. Now take down this diagram first. Take the diagram first. Neeraj, എഴുതുന്നുണ്ടോ? Neeraj, are you writing? Okay. Just take the question. Apply Dijkstra's algorithm. Apply Dijkstra's algorithm to find the shortest path. Apply Dijkstra's algorithm to find the shortest path from the source node S, from the source node S to all other nodes. Source node S to all other nodes. Question complete ചെയ്തോ എല്ലാരും? Anyone please respond? ഇല്ല. Make it fast. Karthik, finish writing? Finished?
Yes.
Yes, okay. Now write down Dijkstra's algorithm. All of you write. Whatever question is asked for Dijkstra's algorithm, you have to just write these steps. Write down Dijkstra's algorithm is used. Dijkstra's algorithms is used to find the shortest path. Is used to find the shortest path from one node to every other node in the network. Is used to find the shortest path from one node to every other node in the network. In this, each router shares the knowledge. In this, each router shares the knowledge of its neighborhood, with every other router in the internetwork. Each router shares the knowledge of its neighborhood with every other router in the internetwork. Finished?
Yes, miss.
Yes. Considering the given example. Considering the given example, the various steps are, write down, step 1, writing all nodes present in the network. Writing all nodes present in the network. That is your step 1. Step 2, assume one node as the source node. Assume one node as the source node. In bracket, you write down, here S is the source node. Here S is the source node. With respect to this problem, it is assumed that S is the source node. Okay. You write down or set root to local node, set root to local node and move it to tentative list. Set root to local node and move it to tentative list. Here root spelling is ROOT. Set root to local node and move it to tentative list. Finished? Finished?
Yes.
Yes. Okay. Step 3. Initially, assume the cost of any node. Initially, assume the cost of any node from the source node. Any node from the source node is not known. Initially, assume the cost of any node from the source node is not known. KNOWN. In bracket, you write down, consider them as infinity. In bracket, you write down, consider them as infinity. Step 4. Among nodes in tentative list, comma, move the one with the shortest path. Move the one with the shortest path to permanent list. Move the one with the shortest path to the permanent list. Fifth step, add each unprocessed neighbor. Add each unprocessed neighbor of last moved node. Add each unprocessed neighbor of last moved node to tentative list. If not already there. I repeat, add each unprocessed neighbor of last moved node to tentative list if not already there. In bracket, you write down, find the adjacent nodes. Find the adjacent nodes. Next step, find the cost from the source node. Find the cost from the source node. Now, out of the values, if less value is obtained, if less value is obtained, update the table. Less value is obtained, update the table. Otherwise, ignore it. Otherwise, ignore it. This is repeated. This is repeated until all nodes are permanent. This is repeated until all nodes are permanent and the tentative list is empty. This is repeated until all nodes are permanent and tentative list is empty. So for any problem, if it is asked, you have to write this much steps and then you have to solve as per the method what I have taught. The method I will be solving, I think the time 3 minutes is not sufficient to solve that. So I'll just solve it in the next class. Okay, so just read, anyone, you just read it, what you have just written. Amaya can read.
Miss full വായിക്കണം.
Yeah, step 1.
Step.
From the steps you read. Yeah.
Writing all nodes present in the network.
ഈ സ്റ്റെപ്പിന് അനുസരിച്ച് you try to just solve it. Okay, അറിയാമെങ്കിൽ അത് ചെയ്ത് നോക്കുക, ഇല്ല എങ്കിൽ നെക്സ്റ്റ് ക്ലാസ്സിൽ that I'll be solving it. Okay.
Step 2, assume one node as the source node. Here S is the source node. Or set root to log.
Or this is another statement. Or set root to local node.
And move it to the tentative list.
Yeah, move it to the tentative list. Okay.
Next step 3. Initially, assume the cost of any node from the source node is not known. Consider them as infinity.
Okay.
Step 4. Among node in tentative list, move one with the shortest path to permanent list.
Okay.
Step
so once
5.
it is permanent, you no need to consider that node again. That is the meaning. Okay. Then
add each unprocessed neighbor of the last moved node to tentative list if not already there. Find the adjacent node.
In bracket you write down the same step. The meaning is you have to find the adjacent nodes to the in which node you are at present. You have to find the adjacent nodes and then you have to solve it. Okay, so that is the statement. Or you can just find, in bracket you have to just write find the adjacent nodes. Now finally
find the cost from the source node out of the values. If less value is obtained, update the table, otherwise ignore it.
Okay. And that process is repeated until all the nodes are permanent and your list is empty. Okay, so you have to find the adjacent nodes. You have to find which is the minimum cost. You make it as permanent. Then you have to, the cost, how you are identifying is from the source node. You have to add it and then put it in the table. Now finally, you have to make all the nodes as in the permanent list. This same question തന്നെ ഇതിൻ്റെ അകത്ത് ഇപ്പോൾ പറഞ്ഞിരിക്കുന്നത് source node S to all other nodes എന്നാണ് പറഞ്ഞിരിക്കുന്നത്. ചിലപ്പോൾ അവർ സ്പെസിഫൈ ചെയ്യും let T be the destination node. അങ്ങനെയാണെങ്കിൽ S ൽ നിന്ന് T യിലേക്ക് എത്താൻ വേണ്ടി which is the shortest route. അത് നിങ്ങളത് ഹൈലൈറ്റ് ചെയ്ത് ഗ്രാഫിനകത്ത് തന്നെ കണ്ടുപിടിച്ചതിന് ശേഷം വരയ്ക്കണം. Okay, so these are the different എങ്ങനെ വേണേലും question ചോദിക്കാം. So the algorithm remains the same. So next class I'll be just solving it. Tomorrow 3 people has to call, Jyotish, then Shruti and Drishya. നിങ്ങൾ നാളെ 10 മണിക്ക് ശേഷം എന്നെ ഒന്ന് വിളിക്കുക കേട്ടോ. Okay, staff has joined. Okay, thank you. We will meet next week. ഹലോ ഷെജിൻ ടീച്ചർ, ഞാൻ ആ റെക്കോർഡിംഗ് ഒന്ന് സ്റ്റോപ്പ് ചെയ്തോട്ടെ. കണ്ടിന്യൂ.